So this is 3.6, first video without my left hand in it, hopefully. We'll see how well this works. And 3.6 is root theorems. First thing we're supposed to do here on the first problem is list the potential rational zeros. And we're going to do this, and you're probably going to need to write smaller than me, but we're going to find the factors of the constant, which is 36, over factors of the first coefficient. Which is the understood one. And again, you need to write small because, that's what you do. Factors 36 written out in order are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus, 9? Then followed by 12. Looks like an 18. And finally, I forgot the plus or minus symbol, plus or minus 36. And you're supposed to guess and check through these and see if, of course, after you write out the list, you're supposed to find all of them. So a couple of these are going to be in the list. And I'm just glancing at it real quick to see what they're going to be. I'm going to focus on these, and I'm going to try and miss one first just so you can see how this works. The idea is a 0 has remainder equal to 0. So I'm just going to do some synthetic division, and like I said, I'm going to try and miss one first. I'm going to make a guess, and I'm going to guess that x equals 4. That's just a guess, all right? Write down my coefficients, which are 1, 4, negative 9, negative 36, and I'm going to drop the 1. 4 times 1 is 4. 4 plus 4 is 8. 4 times 8 is 32. Negative 9 plus 32, because I'm adding down, for those of you who haven't quite grasped this yet, is 23. And 4 times 23 is 92. And negative 36 and 92 is not 0. That's the big thing. It's not 0. So what I just learned here is that x equals 4 is not a 0. Plain and simple. Now, these do factor, so you may not. I was kind of looking at it real quick earlier in a second. I kind of paused for a second or two, and I was factoring it in my head. I know that plus or minus 3 are going to work because I know how this thing factors. So I'm going to try a negative 3, and let's see here. She was 1, 4, negative 9, negative 36. And I'm going to drop, and I'm going to multiply, and I'm going to add, and I'm going to multiply, and I'm going to add, and I'm going to multiply, and I'm going to add. So what I just learned here is that negative 3 is a 0. Now, synthetic division can be reused over and over and over and over. If you get a 0, the next time you do it, you can use the new set if you want. 1, 1, negative 12. And this time, I'm going to pull out a positive 3. I'm going to drop the 1. 3 times 1 is 3. 1 and 3 makes 4. 3 times 4 is 12, and there's a 0. And you could do synthetic division again if you'd like to, but you could remember this is the remainder, this is the constant, this is x. X plus 4 equals 0 is the last 0. So x is negative 4. That didn't go so bad. Hopefully you did that. Hopefully you wrote small. All right. I need to go off to do enrollment. I'll be back in just a minute to finish this up. All right. So moving forward, the task of this one was to find or write 2 other zeros. That's your goal here. You're supposed to write 2 other zeros. It would help if I would use my stylus and not my finger. but you're supposed to write 2 other zeros. And the idea here is that weird zeros have conjugates. That's what I'm going to write, weird. Because that's weird. That's weird. Weird zeros have conjugates. So the conjugate of 5 minus 15i is 5 plus I. Sorry, 5 plus 15i. And the conjugate of 17 plus root 23 is 17 minus root 23. Those are your other 2 zeros. Sorry, I'm still struggling with this. Still am. It's kind of weird for me to write on a tablet, and I'm not accustomed to it. All right, your goal here was to find all complex zeros. That was what your goal was. The instruction set probably says list all possibles, find all complex. All right, so let's talk about our potential zeros. We're going to do the factors of 36, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus, lost my place here, 6, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 36, over the understood 1, plus or minus 1. And then we're going to guess. All right, that's the potential zeros. If there is a rational zero in here, it's in that list. And I actually don't mind, even like dual enrollment teachers don't mind. A lot of teachers don't mind. You just go to your TI-84, because this is time consuming. And let's type the function in. That was x to the 6th plus 4x to the 4th. Of course, if you don't have a TI-84, whoops, pay attention to what you're typing here. If you don't have a TI, stop it. There we go. Scroll over here. It'd be quicker for me to use the keypad than this stylus. What we're going to do is we're going to kind of cheat a little bit. We're going to look at the graph and we're going to pull out a real zero or two. And that's what we're going to do. And if we pull it out once or twice, we should be able to do some synthetic division and reduce it down and enable the quadratic formula. So I'm going to do a zoom 6. Hopefully I see something nice. Yeah, those aren't too pretty. There's 2 good ones in there. I'm going to check them real quick. I'm going to put a 0 in Y2 and just make sure that the rational zeros are at plus or minus 1. They look like they're at plus or minus 1. So see, there's a nice looking 0. There's a nice looking 0. That 0 on the right and that 0 on the far left are probably complex irrational numbers. Or sorry, I said complex. They're probably irrational numbers. They're going to be square roots. So, yes, ma'am. Other than beta, no. Thank you. Thank you. All right. I got my cursor close. Enter 3 times. Oh, it wasn't a nice number. X to the 4th plus, that's why. Typo. Try this again. Second trace, 5. Be a whole different graph. Well, this isn't cool. It's got 4 nice zeros. They're at -2, -1, 1, and 2. Anyways, I still want you to learn how to do the quadratic formula. But so we're going to pull out to, just so you can see the instruction here. What we're going to do is we're going to factor out two zeros. We're going to reduce down to a quadratic. Now the graph told me -2 and -1 and 1 and 2 are zeros. This is coming from the graph. Need placeholders. There is an x to the 6th. There is no x to the 5th. There is an x to the 4th. There is no x cubed. There's a minus 41x squared. There is no x, and there is a 36. And I'm going to multiply, and I'm going to add. So I drop the 1. 1 times 1 is 1, 0 and 1 is 1, 1 times 1 is 1, 4 and 1 makes 5, 1 times 5 is 5, 0 and 5 makes 5. 1 times 5 is 5, -41 and 5 makes -36. 1 times -36 is -36, 0 and -36 is -36, 1 times -36 is -36, 0. Now the graph, and again, these are from the graph, told me that 2 was a 0. So I drop the 1. 1 times 2 is 2. 1 and 2 makes 3. 2 times 3 is 6. 5 and 6 makes 11. 2 times 11 is 22. Interesting. 5 and 22 makes 27. 2 times 27 is 54. Okay, good. -36 and 54 makes 18. Twice 18 is 36, and I have a 0. I pulled out two zeros, and I'm going to pull out two more because I want to reduce down to a quadratic. Quadratic, by the way, being x squared. And I've pulled two zeros from x to the 6th, so I'm only x to the 4th. So now I'm going to pull the -1. Drop the 1. 1 times -1 is -1. 3 minus 1 is 2. -1 times 2 is -2. 11 minus 2 is 9. -1 times 9 is -9. 27 minus 9 is 18. -1 times 18 is -18, 0. And now I'm going to also pull the -2, and again, from the graph. All right, I drop -2, 0, 0, 9, -18, 0. And I have factored it down to a quadratic. This is the constant, the x squared. Sorry, that's the remainder. Believe it or not, this is throwing me off, not having a piece of paper. It's different. This is my remainder, my constant, my x squared. So what's left is x squared plus 9, and that's where the last two zeros are. You can solve this however you want. If you want to factor it, that's where I'd love you to be. It's x minus 3i times x plus 3i. Use your zero product property. Or you can do x squared plus 9 is 0. Shift your 9 over. X squared is -9. X would be plus or minus the root of -9, which is plus or minus 3i, which is exactly what your factors have. So you can do it either way you want. Don't really care. Your goal here is to write in standard form, in factored form, a polynomial with the given zeros. Now, in addition to what's mentioned, you have to use your weird zero conjugates, all right? There are two other zeros. They are 4 minus 2i and 1 minus root 7. And we should know by now, if you take a zero and you make it a factor, you change the sign. That's what you do. We'll just call this thing f of x. Her leading term starts with a 4, because a is 4. That's where that's coming from. And if 3 is a 0, x minus 3 is a factor. If 4 plus 2i, that's a bad looking set of parentheses. If 4 plus 2i is a 0, the factor is x minus 4 minus 2i, because we changed signs. Now, right next to that one, I'm going to put that guy. If 4 minus 2i is a 0, the factor is x minus 4 plus 2i, because I am taking away the number. I know kids struggle with this. If 1 plus root 7 is a 0, the factor is x minus 1 minus root 7. And finally, the last one is 1 minus root 7. And I just changed signs as I entered parentheses. The factor is x minus 1 plus root 7. Ta-da! Not too bad. I love these problems. If you take new enrollment next year, you'll have a test, and this will be on it. Different numbers, obviously. But a farmer is going to use 400 foot of fencing to enclose a rectangular plot that borders a river. He will not fence the piece next to the river. Draw the scenario. So we have a river, and he's going to fence off a rectangular area. It's kind of a lie, too. They actually do tend to put a fence in the river to keep their cattle from going across the river. But anyways, this is the scenario. This is a rectangle. Generally speaking, the way you do these things is you call the width x. And if you had 400 feet to go around these three sides, the length would have to be 400 minus these two x's. That's the setup on these. Accept it in your heart as true and be okay with it, okay? Create an area function written as a function of x in standard form. So you know that the area of a rectangle, at least you had better know the area of a rectangle is length times width. Shame on you. Shame, shame, shame if you didn't. So our area, as a function of x, our length is 400 minus 2x, and our width is x. And I want it in STD form, so I am going to distribute my x. My area as a function of x is negative 2x to the second, because x times negative 2x is negative 2x to the second, plus 400x. Whoop. There is my area function. Find the maximum area possible for the farmer to enclose. And I even said the maximum happens at the vertex. This is a parabola. She opens down. And we're going to use x equals opposite b over 2a. So the x coordinate of the vertex, or my max, is going to be at opposite b, which is negative 400 over twice a, twice a negative 2. That's a negative 400 over a negative 4, which means that x is 100. Now, a lot of teachers teach that you plug that x back in right there, which is fine. But you also have a perfectly good drawing, don't you? I mean, you've got a rectangle. X is 100. I would put it right there, and I'd put it right there. That's what I would do. So we've got 100 for x. 400 minus 200 is 200. And our area is going to have to be 100 times 200. It's a little simpler to do in your head, and that's what I'm all about. I think God made us to be thinking creatures. And I'm all about what I can actually do, not necessarily what technology can do, not necessarily making things hard, making things easy. Now, I learned probably in 5th grade that to do these things, you do 1 times 2, which is 2, and then you just add your zeros. 1, 2, 3, 4, 20,000 square foot is the maximum area that he can enclose, which to a person who doesn't know much seems like a lot. You guys live in rural West Tennessee. I mean, there's things you should know. 1 acre is 43,560 square foot. I mean, half of DHS is in farm. I bet you still didn't know that. So this is less than half an acre. I have no idea what kind of livestock this farmer is using, but a cow typically requires in our area 1 to 2 acres per cow. So this has got to be like a holding pen or something. All right, what's the goal of this one? Oh, this is factor. Look at your instructions, says is factor, do not solve, because there's no equality. This one shouldn't be too bad. I don't think it's going to be too bad. To make a 9x to the fourth, there's lots of ways you can do it. But a 9x squared and x squared will do it. You know, if you try 3x squared and 3x squared, it's worth trying. But I don't think you're going to be able to get to 8. I mean, because to make a negative 1, you have to be plus 1 and minus 1. And I know not everybody in here can do the double distributive property, but that would mean no x squared, and you have 8 of them. So it's going to be a 9x squared and an x squared. And we want to add to 8. So I need to add 9. And I need to take away 1 to get to 8x squared. So there's my initial factorization. And I want you to completely factor. All right, that's the goal. 9x squared minus 1 is a perfect square. Factors 3x minus 1. Sorry, it's not a perfect square. It's a difference of two squares. And 3x plus 1. And then, of course, you have x squared plus 1. Now, this is legit good enough. But if you want to be extra, which I hope you do, meaning you understand mathematics, I want you to be a level 4 kid, mastery, 92nd up plus percentile rank. You'd factor that as x minus I and x plus I. That's what I want you to be. Hopefully you get there. All right, more factoring. So 14 is not too bad. The first commandment of math that I have is if you can pull it, pull it. It's written in Old English. I think it says thou shalt pull it if thou can pull it or something like that. But I notice that both pieces contain x to the fifth. If I pull x to the fifth from x to the eighth, I have x cubed. And if I pull it from x to the fifth from itself, I have the 1 as a placeholder. So what I'm thinking about now on this one is I'm thinking I have something cubed minus something cubed. Something cubed minus something cubed factors is something minus something times something squared plus something times something plus something squared. When I look at this thing, I see that A is x because an x times an x times an x is x cubed, and B is 1. And I'm just going to plug it in my pattern. So x to the fifth stays where she is. A is x, B is 1. Plugging in here, here. Got to square it. X squared plus, because there's a plus. 1 times x is x. Square of 1, you get 1. That is the complete factorization. It is. All right. Last one on this page, and the last one, I guess maybe there's another problem, is x to the fourth minus 81. We have actually factored this in class before. It factors as x squared minus 9 and x squared plus 9. X squared minus 9 factors as x minus 3 and x plus 3. And then you have x squared plus 9, which you can do some extra. We've done this pattern in here before. And that's the complete factorization of that polynomial. So be it. And the last one I'm going to do, 64x to the 6 plus 27x cubed. What can I pull from both terms? I can pull an x cubed. I don't believe I can pull anything else, although I'm pretty tired. I don't see a need to. If I pull an x cubed from 64x to the 6, I have 64x cubed. And if I pull it from 27x cubed, I have the placeholder of 27. Now, this happens to be a something cubed plus something cubed pattern. All right? A is going to be 4x, because 4x times 4x times 4x is 64x cubed. B is going to be 3. And the pattern here is going to be a plus b times a squared minus ab plus b squared. That's my pattern I follow. So everywhere I see an a, I'm a 4x, and everywhere I see a b, I'm a 3. Be careful here about squaring. It's a very common mistake for kids, just write 4x squared, no parentheses, and miss it. Minus 4x times a 3 plus 3 squared. So we have x cubed out front, 4x plus 3. Then we have the imaginary solution, 16x to the second minus 12x plus 9. Complete factorization of number 17. And I didn't break a sweat because that stuff is easy peasy. And that is your 3-6 homework and the first video where you didn't have to see my left hand in the way. I hope that helped.